Hey peoples. All right. So video is pretty quick. It's to help review or to help go over the homework. That was a work energy homework. And remember, this was your first time doing this. So we're all new at this. It's going to take a little while for you to feel comfortable with this material and that's okay. It's usually about a 1 week learning curve before you're like, yeah, I'm definitely getting it and you're just making math errors. So really quickly going through this homework. If you don't want to see this going over the homework stuff, I would fast forward. I would move ahead until you see an image that looks like this, and I'm going to talk about that problem right there. So if you don't want to hear this, skip it. But the kinetic energy can never be negative because mass is never negative and velocity squared has to be positive. Gravitational potential energy can be anything. If you call height 0 where you're standing, then you have no potential energy. If height 0 is somewhere below you, then you have positive potential energy. If you say height 0 is the ceiling above you, then you have negative potential energy. Personally, I don't like negative potential energies, so I always say the lowest part of my story is height 0. This way I'll never go below that. Now, number 3 is pretty straightforward. Again, your goal is to be able to to address this work energy theorem here and be like, is it moving in the beginning? No. That's why I crossed this off. Is it above height 0 in the beginning? No. Are there forces doing work? Yeah, there's an applied force. Is it moving in the end? Yes. Is it above height 0 in the end? No. I'm only asking yes or no questions. Every year there's a handful of people who are like, yeah, it's above height 0, but it's not moving. And I'm like, nobody cares. Is it above height 0? Yes, no. That's it. You can't say anything else. It's just a yes or no question. Don't add anything to it. But this one's pretty straightforward. You just have an applied force of 200 newtons for 4 meters at an angle of 15 degrees. That's the angle between the direction it's moving and the applied force. And that's it. That one's pretty easy. Going down a hill, are you moving in the beginning? No. Are you above height 0? Yes. Is there anything doing work? No, there's no friction. Are you moving at the end? Yes. Are you above height 0? No. So basically, this is a problem where potential energy becomes kinetic energy and the mass divides out. One thing I do want to add is whenever I have an incline problem here, the first thing I do is I write that the height is this hypotenuse distance d times sine theta. And in this case, it's 12.8 sine 35. I like to do a little side calc for that. And there's a reason I do that. But I always do it on my picture. Number 5, this was something thrown down. So it does have an initial velocity. So, oops, where'd it go? Hello, number 5. There you are. It is moving in the beginning. It's above height 0. There's work being done because it mentions the work done by air resistance. It is moving in the end, but it's at height 0 at the end. That's why that's crossed off. After that, pull down your math and sub in numbers. Air resistance will always act opposite the direction of motion. Therefore, it'll always be negative work. Just simple as that. It's trying to remove energy from the system. It's trying to slow it down. Again, do not go from this to an answer. Notice what I've done here is I've written each one of those out. Because let's say you have everything right except for this first one here, and you're not getting 45. You're getting closer to like 4, and you can't figure out why. Odds are you forgot to square. And that'll help both you and I find any mistakes you might make. 6 is kind of straightforward, super easy. This car is moving in the beginning. It stays on a horizontal surface, so there's no potential energy. And then there is work done by friction, and it comes to a stop. So is it moving in the end? No. This one, like the work done, you don't have to write cosine 180 if you don't want to. You could just make it negative work done by friction. It'll always be negative. That's up to you. So we start with potential, do a little work done by friction to bring it to a stop, and you solve for the friction force. Sorry if you can hear my whining cat in the background, who is most definitely hungry. This one is the work done by friction, just straight up work done by friction. I can tell you on a test, you'll never be asked what is the work done by friction. It'll be more like a coefficient of friction. It'll be a little bit tougher than this. But is it moving in the beginning? Yes. Is it above height 0? Yes. Is there work being done? Yeah, we're solving for that. Is it moving in the end? No. Is it above height? Sorry. Is it moving in the end? Yes. I blame my brain right now. And then is it above height 0 in the end? No. So remember, your goal is to figure out if you can cross some things out or not. Friction is always going to do negative work. That's why I made the work done by friction negative. After that, you're just subbing in numbers. Excuse me. So that's a quick discussion of this most recent introductory homework. But the problems, they're going to get worse than this. The purpose of this was to try and get you comfortable with writing out the work energy theorem and deciding what energies to cross out or not. Now this problem would have been what we did in class today. And the purpose of this problem is to show you that there are no more two-part problems at the moment. You don't break problems up into multiple parts. And also we can have a problem with multiple works. And in this scenario, there is a 200 Newton force applied for 5 meters on a frictionless surface, and it's horizontal surface. But then it slides up an incline with friction and comes to a stop. And we want to find out how far along the incline it slides, this distance d. Notice what I've done immediately is to write height is hypotenuse, that's this here, sine theta, or d sine theta. Sine of 30 is 0.5. So I have height is half the hypotenuse, or half the length of the incline. Moving in the beginning, no. Above height 0, no. Is there work being done? Yeah, by friction. That's cool. Is it moving in the end? No. Is it above height 0? Yes. Okay. So there's two works here, and I've written them each individually. One is the work done by the applied force, and one is done by the work done by friction. The applied force acts parallel to the direction of motion. That's why it's cosine 0. Friction, notice I've already made it negative here. It does negative work every time. It's trying to slow it down, take energy away. Is mu times the normal, there's your force of friction, acting for a distance. Don't forget the distance. If you know that the normal force on an incline is mg cosine theta, that's cool. Just use it. I don't need to see work for that. So you have mu, that's here. The normal force, don't lose the distance. Everybody gets so hung up on the work done by friction that you're so focused on, okay, it's mu, but it's on an incline, so that's mg cosine theta. Okay, and then you forget the distance. In the end, you have potential energy. Notice this height final, but we've said that height final was 1/2 the d. If you leave this as h, you're going to have an h here and a d here, and you won't be able to solve for anything. That's why it's super important to put the height in terms of d. Just do d sine theta. It's a right triangle. And then from there you solve. Now, this was me talking through a problem really quick, but there's another video that I posted that has me going through a problem with multiple works in a little bit more detail. And you need to watch that one because it'll be helpful. But for this, I'm just trying to let you know, no more two-part problems. Don't make it a multi-part problem. The cool thing, amazing thing about work and energy is that all it cares about is what kind of energy do you have in the beginning, what kind of energy do you have in the end, and is there any work being done anywhere in between? Like, that's it. And that's how you set it up. You don't break it up. Do not try to find the final velocity here and make it the initial velocity for the next part. Do not do that. You are literally doing twice the amount of writing, twice the amount of work as somebody else who can simply just do it in one step. So anyway, I'm going to stop this video now, and I hope it helped. I don't know. Take care.